tutorial series. So this conductivity tutorial series is going to be a 15 days series, starting from the introduction to the end of the sessions. We are going to take many examples wherein we can fit in our conductivity to solve our use cases. Okay, so let's go ahead and see the what conductivity altogether is. So conductivity is a set of tools which are helping us to create, manage, and run the large-scale data processing systems. So when we talk about large-scale data processing system, we can call it as an end-to-end data processing system. So Graph is also a data processing unit. So this is small data processing units, and we make the graph for certain jobs to be done, like let's say data extraction or data unload or data load, or and in between the data transformation for certain small set of data or set of feed. Okay, so if we constitute all the units together, or if I were to define the conductivity is the it's a set of graphs, you know, or connected together, set of graphs and also the conditional logic connected together in a meaningful way, or according to the conditional logic, or the concurrent graphs, concurrent run units, constitute the a different graph, making it as a meaningful and sequential or probably the concurrent data processing system to solve our a particular use case. So if we talk about simple use cases wherein we are unloading the data and then validating the data and transforming the data, or enriching the data and then preparing the data in a uniform format, and then we are sending the data across to the third parties or to the databases or somewhere else. Okay, so if the whole set of units, right, from end to end, we can club together, or we can make it as a one data one processing system, so then we can call it as a conductivity. So each and every unit has meaningful meaningful existence within the conductivity. And conductivity contains a framework. Within that framework we have plans, we have graphs, we have subplans, we have and within the subplans we can create subscriber plans and looping plans and the program task. If you look at the complete toolbox of conductivity which it offers, is just a small snippet of all the the library which it offers to create a meaningful unit of work. So this is a conditional task, right? So depending upon certain condition, certain expression or a certain script, right? So this piece of I mean this component can be used, and then there is a conditional graph task, sorry, continuous graph task. Okay, so we can have a continuous graph call within the plan, so that we are going to see one by one all the components, and then graph task, then plan task, and then send event. So there are events produced by a particular graph, and there is a combination of sending the event and wait for event. So if we were to send an event, let's say X event, and there would be some the component which is going to listen that event. So if we want to execute, our plan is getting executed, and depending upon the success of the plan, we are going to trigger one sub other plans. So within the same host. So this is the condition. So this should be residing on the same host, a computer where the things are running, right? Then the host signal signal event and wait for event is going to be used. Then there is a sub plan. So within the sub plans, there we can produce the looping plan. That looping can could be sequential or concurrent, both of the so that the parallelism we talk about in the graph, right? So same kind of parallelism here also can be produced by looping concurrent plan, basically, right? and then there is a subscriber sub plan, right? Within these sub plans there is a graph task, right? And we can add many more component within the sub plan as well. And this piece of looks is a plan, you know plan within a plan, and the nested plans. Okay, and then there is a wait for file is also a component. And so this is the whole library which we are going to touch upon one by one, and depending upon our use cases. Okay, and yeah, we are going to create the different plans. Okay, so let's switch on to a little more theoretical aspect of it. So we can design, develop or unit test and deploy and manage. So these four tasks which are very prominent for a particular ETL pipeline is to design the things based on requirement, or based on meaningful sequence of events or parallel events, right? And then develop, because we have the vast tools or vast framework to develop the things, and we can unit test it, and we can deploy it. We have so the in background, the operating system and the technical repository are working as a same same set of units as we as it is done in the graph, graph deployment and graph check in check out process. So the same thing, the plan is another another unit of work, or another thing which we can uh, check in as well and deploy into the higher environment in the same way. And then we can manage whenever it is there in the our production system or in a testing environment. So because it allow us to solve the complex use cases. So when we are going to develop the end-to-end system, so we can build the independent unit. So let's say we are working with the number of people. So we can assign a particular unit of work or particular processing unit to the people, and then after that we can integrate to make it a robust system finally. So yeah, we can track it. There are different tracking than graph. So there is a meaningful, and there is a verbose tracking displayed while plan execution, and then we can debug the units, and we can uh, place the kind of break break the units to debug the complete system. And there could be recovery mechanism. So the recovery mechanism which is offered in graph processing, right, phases and commit checkpoints. So here the recovery is going to be a little bit different. And in addition to the graph task which is eventually running the graphs, so in addition to that we will have many more recovery options over here in the case of plan. And then we can run tune the resource usage, right. So that is also another feature of conducted IT is that we have resource control. So resource in the sense of, if we are many database hits are happening from a particular processing of conduct IT, maybe plan. We are processing the plan and it is hitting the database parallelly, and so depending, we can limit those database hit, and we can limit the concurrent processing as well. So the CPU cycle, if it is going beyond the limit, so those kind of resource usage limit can be. We can create the resource pool, and then within the resource pool we can create many resources, and then assign the resources based on the demand. Okay, so that is another prominent or very important feature as part of conduct IT. And if you talk about the interfaces, how we can manipulate and create the conduct IT. So we have a graphical user interface which is supported by GTE, the same software, and the command line. So we have operational commands and utility commands. So operational commands is to running the plan and setting the AIR plan, set admin commands. Okay, plan admin command, administrator related operational commands, right? Setting the parameters, recovering the parameter, and removing the recovery files and restarting shutting down the plan, and the resource usage commands basically. So these are the operational command, and then there is a utility command, which are m underscore plan to create plan, or the m underscore pool. So creating the resource pool and creating the plan. Okay, and editing the plans using the commands can be done as part of these interfaces. So this is the whole kind of introduction. So this is complete library of components which we can work upon one by one. So I have designed a kind of sequence of course actually. So this is going day one. So we have kind of introduction of conduct IT, and then there will be a kind of we will see through the use cases wherein possibly we can use the conduct IT as a solution. Okay, and in the third one, I mean we are going to see the use cases first, and then we are going to learn about it, the in-depth knowledge of conduct ID and the plans, and what is plan and what is the sub-plan, looping plans, and how we can create a sequential and concurrent and task and method, etc., etc., as part of volume 2. And in volume 3 we are going to understand about the parameters, how the life of the parameter is going to be there in case of conduct ID, and how parameter passing happens, right? So that we are going to understand, and in as part of volume 4 we are going to understand the plan and recovery. So plan recovery, so I was talking about, we can produce the recoverable plan, right? So they are self recoverable basically. So we have to code the plan in such a way that in event of failure they can recover self recoverable plans. They can recoverable automatically, right? Without altering any piece of data, enter. Okay. And then there is a resource management. So one volume I have dedicated to the resource management, how to create the resources and how those resources can be utilized by different, running plans. Then there is an, so this parameter in conduct ID is different from this parameter in parameters in conduct ID. So that also we are going to understand. There are some inbuilt parameters, right? Those we are going to into it, look into those. Okay. So then there is a conduct IT commands. So I was talking about operational command and utility commands. So those commands, the necessary commands, we are going to look into it. Okay, and then conduct IT events. So this is also a kind of a salient feature of conduct IT, wherein it allows us to creating the events and sending the trigger to the following plans, right? Then continuous graphs in plan. So we can have a continuous graphs in plan. So we from within plan we can call the continuous set of units. So let's say we use batch processing, and we want to trigger a continuous processing later on, right? So that kind of arrangement can be done as part of this graph in plan. Okay. Then we are going to understand finally the difference between graph and plan. So what use cases can be solved or should be solved using a graph, and what we cannot do, and what plan of has to offer after learning everything. And then we are going to understand five different use cases as part of plan and conduct IT. Okay, so this is a complete set of things we are going to do as part of 15 days plan and conduct IT sessions. Okay, thank you so much. Please subscribe my channel, and